Hello Jaguars, Mr. Graul here. Today we're going to be working in Flash, which is a animation program that also has an associated programming language called ActionScript 2. Now Flash was formerly owned by Macromedia and they were bought out by Adobe. We have the older version. The newer version uses ActionScript 3. But ActionScript 2 will teach you many of the same principles of object-oriented programming. I'm going to go ahead and run this program. And all we're going to try to do is get the moon to orbit the Earth. Now I did put a unit circle which is used in trigonometry to sort of give you an idea of what I was trying to do here because I had to use some trig. And as I incremented the angle, you'll notice that the positions that are located here, the x position and the y position on the coordinate grid, are listed for each angle. So as I incremented the angle, I got the cosine and the sine, and I commanded this ball to go to that position. And I used a timer to make it continuously upgrade and increment the angle, so it continuously would upgrade and increment the x and y position also. So that's what we're going to learn. I'm going to go ahead and shut this down. I'm going to jump over to Photoshop for a minute and talk a little bit more about this unit circle. When you have a position on the unit circle, by the way, all the data in trigonometry, when it returns a value, it goes to a lookup table, looks it up, and returns a value to you. So in this case, say I wanted the moon to be 30 degrees. I would say math.cosine, and then I would feed it the angle, but it wouldn't be 30 degrees. It would be pi over 6. Because in trigonometry, they use radians. They don't use degrees. Now, what is a radian? This line right here, which just happens to be a unit of 1, is the hypotenuse. And of course, if you remember, your cosine is the relationship of the adjacent side to the angle. Here's our angle of 30 degrees over the hypotenuse. Well, the hypotenuse is always going to be 1. So we don't have to worry about the hypotenuse. All we got to do is worry about this value right here. And so what the cosine of 30 degrees is will give you this x value, which is the square root of 3 over 2. And the same thing over here. For its vertical position to be on this unit circle, the y position is now, this distance is 1/2. Okay? So what does the pi over 6 mean? You know that there are, in a circle, to make a circumference, it's 2 pi r, and pi is about 3.14. To go all the way around this thing, you have to go 2 pi times. All right? So when you go 30 degrees, well, the whole thing is 360 degrees, so you've gone 360 over 30, so you've gone a 1/12 of the way. So that would be pi over 6, okay? In other words, it would be 2 pi over 12, which would reduce down to this, okay? So what you want to go is a 1/12 around the entire circle, okay? So that's kind of that. Now, I know trigonometry requires a little bit better explanation than that. Let's look at this real quick. If you ask for the cosine of this particular angle here, which is 120 degrees, in this case, it would return to you the x and y values would be right here. You're going this way, this is 0, so you get a minus x value of 1/2. And you're going positive, so you get a positive square root of 3 over 2 here, and that would locate this position. Now these values are not very useful because when you use them in Flash, Flash looks at this and says, well, I'm going to move it over a half a pixel. I'm going to put it at a half a pixel and up a square root over 3 pixels. That's just too small. So we'll take these values and multiply them by 100 or something. And we'll put that into a variable called diameter. And we'll take the sine and cosine and multiply them by that. Now, if you want to really dig into trig, I have a website here that I'd like to show you called khanacademy.org, where they have everything you ever wanted to know about science and math. Right here you can see each of these is a link to a 10 to 15 minute video on any given subject in math and science. In this case, I'm looking for the trig series right here. So they have looks like about 20 or so things on trig. So you'd want to definitely look at the unit circle definition of trigonometry. I'm clicking on it here, and you would just click here and play it.
We're now going to study the unit circle a little bit more and see how it extends I guess we could say, the traditional SOHCAHTOA definitions of functions, and how we can actually use it to solve for angles.
Okay, so I'm going to go ahead and stop that, but I would certainly come here. There's just a wealth of information. If you want it full screen, you just click on this button down here. I'm not going to do that right now, but it'll make it full screen. I'm going to go ahead and shut this down and shut down Photoshop. Don't want to save it. And no. Let's go back to Flash here. Now I'm going to get a new file here. And I have already made everything I need for this in Photoshop, which I'll teach you how to do. So I'm going to go ahead and import this. So I'm going to go to File, Import, Import to Library. And I made a folder in my documents called Trig. And these are what I need. I'm going to go ahead and open them. And it puts it in the library. If you don't know how to get to your library, you hold on Control and do L for library, and it'll bring it up. These things are sitting in the library now. I'd like them out on the stage. I would like the stars here. Stars here. I spelled that wrong, so backspace. So I'm going to come here to stars and drag that out. In order to get this centered on the stage, I'm going to click on the properties of this bitmap and give its X position as 0 and its Y position as 0 and hit enter. And then I'm going to go ahead and lock this. Now the reason 0 and 0 worked for its X and Y coordinates is because Flash starts measuring from here. This is 0, 0 point, and it assigned the position of this thing. It could have chose the center or an edge. It happened to choose this, and that's something you have some control over. I'll talk about that later. So it fits the stage perfectly. So I'm going to make another layer here and call this Earth. And I'm going to go ahead and drag the Earth out here, and I think I'll cut and paste it, Control X, Control V, and that puts that in the center. And I'm going to go ahead and lock this too, so I can't inadvertently move that or the stars around. And then I don't think I locked the stars yet. Yes, I did. Let's make sure those are locked. Yes, they're locked. All right, so now I'm going to make one more layer, and this is for the moon. And I don't have a moon here, so what I'm going to do is make one. I'm just going to drag out a circle. Now if you hold on Shift, it'll constrain it to a circle. And it applied a gradient. I'm going to go ahead and zoom into that. And I'm going to click on it, come over here to the color mixer. And if I wanted it just solid, I'd say solid, and it'd be solid. I think I'll go back and do a radial gradient and maybe change this color to something else. We'll just make it red for the heck of it, okay? And now we'll zoom out. Let's see what we have. And to zoom out, you hold on Shift with the magnifying glass. So I'm going to zoom back in here. Now right now if I run it, Control Enter, it doesn't do anything. So one more ingredient, we have to make another layer here. And this is where our actions go, our behaviors, our code. Now to bring up your code, you click on this and you hit F9. Now I can start writing some code. Now before I do anything, I'm going to go ahead and establish my variables. So I'm going to type in var. And remember I said we're going to have to multiply that the cosine and sine that we get, those x and y positions are too small. We got to multiply them by something. So I'm going to make a variable called diameter. And I'm going to hit colon. And it's going to be a number type. I'll go ahead and hit enter because it highlighted it. And it's going to be equal to some value. Now I can easily change this later on, and then to end my statement I do a semicolon. So I've just established a variable that holds some data. It holds the number 140. I'm going to make another variable here that's called angle. Now remember, I'm going to be incrementing this. This is also going to be a number, and for now I'm just going to make it 0 and a semicolon to end my statement. Now I'm going to be constantly incrementing that angle. So I'm going to make a variable to do that. And I'll just call it increment angle. And that also colon, what kind of data type is it going to be? It's going to be a number data type. And what it's going to be equal to is, it's going to be equal to 2 times pi divided by something. Remember, 2 pi is a complete circle, and then I can break it up any way I want. So to do that, I'm going to say 2 times, which is shift 8, times some number. So I'm going to bring up the class, the math class, M-A-T-H, we'll do a dot, and start typing P-I, and there it is. So there's your math pi. That particular class, the math class, this will return pi 3.14. Actually, it's got a lot more decimals to it, but we'll just leave it at that. And then we can divide it by something. If I divide it by 360, because math pi is a complete circle, this would return 1 degree, the equivalent of 1 degree but in radians. Well, that would be kind of slow, so I think I'll do it about maybe about 60, and that'll be a little bit faster, but we can play with that number too, and I'll go ahead and end that statement with a semicolon. So that's what I'll increment. The angle will start at 0, but I will keep continuously incrementing it. And then I have to have some kind of position where all this starts, because if I didn't position it someplace, it would do it in the left corner, because remember, that's where the 0, 0 is, in the upper left corner of the stage. But I want it to go around the Earth. So I'm going to have it go around the Earth by positioning it there. So I'm going to say the X position. I'm going to make a variable var X position, and I'm going to have that X position equal to the Earth's position. Now we haven't named the Earth yet, and I'm going to do that in a second, but the name I'm going to give it is going to be Earth underscore MC dot underscore X. Now the name of that, and I'm going to do a semicolon and explain this a little bit to you. Var means it's in blue. It's a key word. It has great meaning to Flash. It says you're making a variable. The name of the variable is descriptive. I just made it up. It's X position. You notice the first word is lowercase and the upper one is uppercase. That's a convention. You don't have to do that, but it's a good idea to do that. I did it here too. Lowercase and then uppercase. Most Flash programmers do it that way. What is this? This is a instance name I'm going to give the Earth, okay? And this is a property of this object because I turned it into a movie clip. Now I haven't done those things yet, so not to confuse you, I'm going to just put the code off to the side for a minute and do that. I need this Earth here to, I'm going to have to unlock these things because I can't click on them. Okay. This Earth needs to be a symbol, so I'm going to right click on it and convert it to a symbol. And normally what you do is you type MC for movie clip class underscore whatever descriptive name you want to give it, MC underscore Earth, And I'm going to make sure the registration is in the middle, so it thinks of the center of it as the center, because you could put it up here in the upper left, and then it wouldn't go around too good. I'm going to go ahead and say that. Now to talk to it in code, I have to give this movie clip an instance name. So normally what we do is we just reverse it. We do Earth underscore MC. MC stands for movie clip. That's a class that has all kinds of properties that allow you to manipulate it. It's a built-in class, and we'll talk about classes later on, but this could get to be a real long video if I started going into all that. But anyways, it has an instance name so I can talk to it. Same thing with this. This needs to be a symbol too, so I'm going to convert it to symbol. And in this case, we'll call it MC underscore moon. And then we will say OK to that. It's a movie clip, and give that an instance name. We'll just reverse it. We'll call it moon underscore MC. Okay, now I think we're good. Let's go back to our code. Let's click right on that A. Notice when that there's a little A there. It means that there's some action script in here. And I'm going to make a Y position. Var Y position. And remember, that's supposed to be capital. Y position. And the data type, colon, is going to be a number. And it is going to be equal to the Earth underscore MC dot. And you notice these are all the movie clip properties that I could choose. In this case, I want its X position. So I'm going to do underscore. It's Y position underscore Y. And then a semicolon, and I forgot to put the data type here, so I'm going to do a colon, and the data type is a number. So now I'm going to know exactly where the center of the Earth is by using these variables that hold the data. It knows where these are now, so that's good. So to move on, and doing your variables is probably the most important thing you're going to do. And I'm actually done with my variables for this particular one. Now I'm going to make a function. What a function is something, it has a block of code that you can execute. We're actually going to put a block of code that moves the moon around the Earth, and we're going to call on that function continuously. We're going to use a timer to do that, but we have to make the function first. So I'm going to type escape, and then hit F and then N, and it'll build the structure of a function for me, so I don't have to type all that out. And it put the cursor there. It wants to know, well, what do you want to call the function? Well, give it a descriptive name. I want to move moon. You notice I use the same convention, lowercase and uppercase. Now here's the function, and then you have these little curly brackets. And now in here is where your code goes. So I'm going to go ahead and hit enter and start typing some code. The thing that I want to do is, first of all, I want to increment the angle. Right now the angle is 0. See, angle is 0, so I want to increment that. So I'm coming down here, and I'm going to say angle plus equals, and all that means in computer talk is whatever the angle is now, add to it. If it's 30, add whatever this number is to it. That's what plus equals mean. So what do I want to add to it? I want to add the increment angle. I want to add to it the increment angle. Well, what is an increment angle? It's pi, 2 pi divided by 60. So let's go ahead and just type the variable in there, increment angle plus equal, and you got to spell it right. If you don't spell it right, it sure won't work. Increment angle. Probably a good way to do it is just to copy and paste. Angle plus increment angle. And then you just do it a semicolon. Okay. Now, the next thing we need to know is we have to position the moon. So let's go ahead and hit enter and position the moon. The moon's name is moon underscore MC. So I'm going to type moon its instance name underscore MC. And the property I want to deal with right now is its x position. So I'm going to do dot to get all the properties and methods of the moon class, of the, excuse me, movie clip class. And what I'm interested in right now is its underscore x value, which is just its x position. And that is going to be equal to the x position. Remember, we created x position, which is the center of the Earth. So I'm going to type in x, position, the x position. And then we're going to add to it the cosine of the angle. Okay, so we're going to say plus. Now the cosine is part of the math function, so you have to type in math dot cos, and I didn't get a plus sign there, so I got to have a plus there. You notice it turned blue. And then let me do that again. Dot cos. When you hit enter, it should give you some parentheses because it wants a number. What number is that? Well, we want the angle, angle, and then a closing parentheses. Now remember, that's going to return a number 1. It's going to be less than 1 or greater than -1. That's not very useful, so we have to multiply it by something. Multiply shift 8, excuse me. And we got to multiply it by the diameter, which is 140. And we can easily change that. So I'm just going to say diameter for now. Okay? And then a semicolon to end the statement. One more piece of code and we're done. Actually, I'm going to copy and paste this because the next code is very similar. Control C, Control V. I don't want the X position, now I want the Y position. And I don't want the cosine, I want the sine, you know, the vertical position. The angle remains the same, and I'm going to multiply it by the same diameter. Hopefully, it'll start going around in a circle. Now, if I run this right now, Control Enter, nothing is still happening because we haven't called the function. So I want to continuously call the function. So Flash gives us a way to do that with a timer, and I'm going to give it a variable name. This is just the way it's done in Flash. I'm going to just call it my interval. You could name it anything. That's a variable. And I'm going to have it equal to, this is the keyword, set interval, and it turned blue. And this is a kind of a function, and it wants, when I make a parentheses, it wants two pieces of information. It wants to know, well, what function do you want to run? Well, the name of our function is called move moon, and I'll put it, and then there's a comma there, and it wants one more thing. It says, well, how often do you want me to do it? How quickly do you want me to do it? And this is in thousandths of a second. If I typed 1,000 here, it would do it every second. That'd be kind of slow. I'll do it every 100,000. Every 100. That means 100 thousandths or a tenth of a second. It'll move it. Okay, and then I'll close the parentheses and give it a semicolon. And that should do it. That should get that thing going around in a circle. Now, what you do is you say a little bit of prayer. One thing you can do is click on this blue thing and check your syntax. And it says no errors. You can auto format it, and so it looks pretty. And then you can run it, see if it works. Control Enter. Wow, it's working, but it's going right off the page. And actually, it's coming way in to the Earth's position. So I got a little troubleshooting to do. Let's go and look at the position and see. Okay, I found the error, and you'll have to troubleshoot this too. I've got the Y position of the moon going to the X position, so not good. So we'll try the Y position. Let's try it again. Hopefully that much better. Much better. So you'll have to do a little troubleshooting. You know, first time around, yours is going to be like mine. It's not going to work, and you hate to see it happen, but it happens to everybody. Now it seems to be working pretty good. Let's close this down and play with some of these numbers. What if I made the diameter less? Let's make it, I don't know, 30. Let's run it now. See what happens. Well, it's going around the Earth, but it's going around inside of it. So Let's shut that down. Let's go back and let's make it 200. Run it. Now it's going around on the outside, further out. Let's put it back to about 120. And we'll run that and see. So we'll leave it there. Let's see some of these other things. What if we change this? What if we said 360 and ran it? What would it do? It would slow it way down because you're dividing by a bigger number. Let's go ahead and shoot that down. Let's put in 20 here. Now it's moving, it should move a lot faster. All right, we'll go ahead and put that back to 60. And we won't play with this. I was going to see if there's anything. On this particular one, there's not much. You could control the speed from here too. If you wanted it slower, say you typed in 1,000, it would only move every second. So that slowed it way down. So we'll put this at 50 thousandths of a second. That should speed it up. Okay, there's a lot to learn, and I'll try to go over this in class a lot more so you can get it. And here's your enrichment assignment. I've got this going around the Earth. Can you get the Earth going around the Sun with the Moon going around the Earth? Think about that, what you'd have to do. In fact, let's just think about it together. This was all about this moving around this. Well, you'd have to make a sun, but everything you did with the moon in relationship to the Earth, you'd have to do the Earth in relationship to the sun. Okay? And you'd have to give it some thought. But a lot of the same code that's right here would just simply be duplicated, but instead of the using the Earth as your position, your X and Y position, you'd be using the sun's X and Y. Well, I'm going to let you think it out. God bless and good luck, and we'll see you in the next video. Bye-bye.